Okay guys, today we're looking at graphing polynomial functions using roots and end behavior. So here is a polynomial function. A polynomial function is the sum of power functions. So for example, a power function might begin with 4x to the fifth. That would be a power function. And it's the sum of power functions. So the next power function might be 6x to the fourth. And then the next power function might be minus 3x cubed. And the next one might be 2x. And normally I would do a square. But sometimes a power function might be missing, okay? So 5, 4, 3. I'm going to go ahead and skip 2. That would have been a plus 0x squared, okay, in here. So I'm going to just jump down to 2x plus 6. So just so you know that sometimes power functions might be missing an exponent. And when it is missing an exponent, it is 0 for the coefficient for that missing power function. Remember, the number on the end is called the constant. Okay? So n, that's this leading power function, is the degree of the polynomial. Very important. So whatever that leading power function, the exponent, that represents the degree. So the degree of this polynomial would be 5. The degree would be 5. You would not use any of the smaller exponents. Always look at the biggest exponent for degree. Okay, so now let's take a look at graphing. It says determine the degree and roots of each polynomial. Use your graphing calculator to help sketch the graph. No y-scale. So we're going to try to do this without a graphing calculator. We're going to go ahead and first determine the degree. So notice that we are in factored form. So you cannot determine the degree in factored form. You're going to need to multiply these together. So multiplying these two factors together, if I FOIL, first terms, and then the outer is 3x, inner is negative 2x, so that gives me, when I add those together, x, and then the last terms is negative 6. So now we're in standard form, and we know the degree of our polynomial is 2. So the degree is 2. So when you have a degree of 2, okay, you're going to look at the parent for that degree. And the parent for degree 2 is y equals x squared. So remember that when x squared is positive, it opens up. So when we're talking about end behavior, you have to look at the degree, go to the parent for that degree, and if it's a positive number, the leading coefficient is positive, then it's going to be opening up on the ends. So we know that this function is going to open up on the ends because it's positive x squared. The leading coefficient is 1. So finding the roots, we know how to do this. We have a root of 2 and a root of negative 3. So the first thing we do is we plot the roots. and then we know it's going up on both sides. Okay, and so we're going to go through there and through there. Okay, so next, so we have a degree 2, and since the leading coefficient is positive 1, it's going, the end behavior would be up and up. Okay, so let's take a look at number 2. So here we have factored form, okay, and so we want to get the degree. So a really quick way, when you're in factored form, a short way to get the degree is, since we're multiplying the factors, all we have to do is add the exponents. So this would be x to the first, and this would be x squared. So 1 plus 2, so this would be a third degree polynomial. And the parent for third degree is going to be x cubed. And the parent goes down on the left and up on the right. So we know that this graph, since it's a third degree polynomial, is going to go down on the left, up on the right. Again, this is going to be a positive leading coefficient, just like the parent. So let's put in our roots. So our first root, so our first factor. Remember, to find a root, you set the factors equal to 0. Remember that this is x minus 4 squared, so that would be x minus 4 times x minus 4. So we have a double root here at x equals 4. So we're going to put a point at 0 for this root and 4 for this root. Okay, we know that since it's cubic, it's a third degree, it's going to go down on the left and it's going to go up on the right. Now, this is a single root because it has an exponent of 1 on it. This one is a double root because it has an exponent of 2. So turn your papers on the back. If you have a single root, it's going to cross the root. For example, if this is the root, it would cross it like that. If it's a double root, it's going to touch, or another word would be bounce off the root. So for example, if this was the root, a bounce, it might come down, touch it, and bounce right off. See the difference between crossing the root and bouncing off the root? So here at 0, it's going to cross. And then at 4, it's going to, since it's a double root, it's going to touch it and bounce off of it. So notice the end behavior, it's third degree, so it's going to resemble a cubic, down on the left, up on the right. So I always start on the left, I go through, it says to cross, because it's a single root. And then the next one is a bounce, so I have to loop it back down and bounce and go back up. Okay, let's take a look at number 3. This time we have a third degree. And so since it's a third degree, we're going to go to the parent function, which is y equals x cubed. Now notice the leading coefficient is negative. Okay, so when you have a negative, instead of going down on the left and up on the right, we're going to go up on the left and down on the right. So we have a double root or triple root this time. a triple root. So we'd have x minus 2, x minus 2, x minus 2. So x equals 2 is our root. So we're going to have a root at 2. But what do we do here? We don't cross because it's a single root. We don't bounce. So go over here to your triple root. Here you're going to wiggle through it. And that looks like this. To wiggle through a point, you're going to come down here and you're going to kind of curve through that point and then curve down. Or it could go up like this, wiggle through the point like that, depending on the direction of the graph. This is also called a saddle point, like sitting on a horse, the saddle. Okay, so again, looking at your end behavior, it's going up on the left, down on the right. So we're going to go from up, come down, and wiggle through it, just like that. So it kind of curves through it and curves back down. So whenever you see that wiggle, you know that that's a third degree root. There's 3 of them. 2, 2, 2. Hey, there's my number. Okay, let's take a look at number 4. So here, remember, to get the degree, since we're in factored form, you could multiply this out. We could distribute. Let's do that. This would be an easy distributing problem. So we'd have negative x, 2 plus 1 is 3. And then negative times negative is a positive, 4x squared. That's a simple one. So it's cubic. So we go to the parent. But it's negative leading coefficient, so we go to this one. So it's going to go up on the left, down on the right. So it's going to go up on the left, down on the right. So we have a double root at 0, and we have a single root at 4. So up on the left, down on the right. So remember, when you have a double root, it's going to bounce, touch it, and bounce off of it. And then when you have a single root, you're going to have to curve it back down and go cross it for a single root. Bounce, cross. And when you make this loop in the middle, you can just approximate a little u between. But if you want an actual point here, you could plug in halfway between 0 and 4, 2. You could plug 2 in for x and find out what that y coordinate is, but that's not necessary right now. Okay. Look at number 6. Well, we can easily say we're in standard form here, or sometimes known as general form for polynomial. It's in descending order. We can see the degree. Remember, since we know it's a third degree, we look to the parent to find out what the end behavior is. It's a positive leading coefficient, so it's going to go down on the left, up on the right. Now, for this one, we would have to factor it to get the roots, to get the factors in order to get the roots. So notice there's an x in common. So we're going to factor out an x. Then you can use the x factor to factor this. Now notice we have a root at 0, x equals 0. And then we have a root at x equals 2, and this one is a double root. So we know what's going to happen there, hopefully. So down on the left and up on the right. Single root, cross, double root, bounce. Okay, so we're running out of time. I'll see you guys tomorrow. Make sure you're ready